welcome back to our YouTube channel, Becoming a ROS Developer. Today we have a presentation for the course ROS 2 Navigation in 5 days. At the end of this course, you can complete a project which you then implement on a real robot. So that's what we're going to be seeing here today from our student, Dura. How are you, Dura?
I'm fine, thanks.
Great. So whenever you want, you please start sharing your screen so you can tell us what you've done with this ROS 2 navigation project.
Yes. Can you see my screen?
Yes, we can.
Okay. So here on the left, I have the RVs 2. Let me move this away. Okay. I'll open the config file so I don't have to do them manually.
Great idea.
Now I'll launch the path planning service. Now I will have to give the pose of the robot, the estimate pose.
Yes.
I think it's about something like this. Okay, it's not exactly perfect, but after I remove the robot a bit, it will center itself.
Yeah.
Okay, so this map that you see here, I've built it 1 hour ago, a little bit earlier, with the cartographer, and now I'm using it for the navigation. So I have a service that I can turn on with this command to save multiple spots on the map.
All right.
So for example, I'll put the no, not this. For example, I'll put the robot here. Now it's navigating. And if I run this command, with the label start, now if I look in the editor, in the one moment, spots to nav, I have the empty file with just the name of the service. For example, now I would like to say to save this spot as pedestrian, for example, and if you take a look, it is saved. I save the position X and Y from the position and the orientation Z and W. Let me move again the robot in another place, for example, here. And when the robot has moved, I'll save also this spot with the label corner 1. This stopped. I think so. Yes. So now I have also the corner 1. Let me move it again. For example, here. And I'll save this with the label corner 2. And I also have this spot saved. Okay.
Cool.
Now I can navigate to these points using this command. Oh, 1 second. Yes, it already gave the corner one spot to nav to.
I see.
Okay. Now I will give it to it the pedestrian, and the robot should navigate here. Yes, you can see here. It hit the traffic signs. I see.
Yeah, sometimes it doesn't catch them with these new wooden ones. So I think
Yes.
that's what happened there.
This is the first time this happens to me. So, and I also can navigate to corner too.
Awesome. And this last node is a client then that is reading that YAML file?
Yes, it's reading 1 second. So it gets the spot, the label that I want to search for in this file, in spots2nav.yaml.
And you load it as a parameter, like parameter. That's why when you did start, we had the name of the node and then the ROS underscore parameter, right, in the YAML.
Yes.
Okay, nice. That's cool.
I think that's it with this. I also have a short PowerPoint presentation.
Yes, please go ahead. Okay. Now we see that really quick, really streamlined on your application.
Okay.
It's cool.
So the project is split in 4 parts. The first one is mapping that I explained when I started. So you have to place the robot on the map. You explore the map with the robot, you build it, and then you save it. After that, you give this map as a service. So then the robot should localize itself on the map. Also, a very important part of this project was the path planning. And finally, the program that records multiple spots on the map, and then making the robot able to navigate to these specific points. I will speak more about the spot recorder and navigation to these spots and how this works. So for recording the spots, this program subscribes to the pose topic to extract the coordinates for the position and orientation of the robot at the moment. Creates a spot recorder service with a custom service interface. When started with label, when it's called with the label start, it empties the YAML file and just writes the first 2 lines of configuration. When it's called with another label, it writes the label down and saves the coordinates of the robot. And for the navigation to these spots, I've declared the parameters for the coordinates of the spot, then get those coordinates from the YAML file, and then I call the navigate to pose action with the desired spot, with the desired coordinates of the spot. Mm-hmm. So the robot will navigate to it. And that's it.
Awesome. Great. So we can give me a little applause. Really, congratulations. Really simple and really straightforward, which means that you've worked on this to debug everything. I have a couple of questions, if that's okay.
Yes, sure.
So first, a couple of visualization things. A lot of our students that have been doing this course have trouble displaying the cost maps like you are doing it now. So you can see the local.
I've also had a little problem, not with the cost maps. I don't know why, but I have a little problem with the robot. As you can see, when I'm in the with the real robot, I can see the robot, but when I'm in the simulation, it works.
Yes, that's most likely because we're not publishing the robot description file that you can then load on until the robot into the robot model element in RViz.
Yes.
So that's why you don't see it. So if you were to basically download the URDF and then add it as a file, you would find it. But I think it's a little less important when you, like, for example, for me personally, I never like add the robot. I just want to see the frames basically,
Yes.
and the footprint, for example. But
the footprint is important, and the cost maps, I think, also are very important.
Yes, I think they're very important. So the main point here is that if you are not seeing the cost maps, I think the issue here is setting the QoS topics
Yes.
that they must match, and then there's a weird thing in the parameter files for your navigation setup in the local cost map and global cost map. You must set all the booleans, so like true and false, to start with a capital letter instead of
yes.
small
Some of them were with capital letter, some of them were with small letter.
Yeah, so a little bit of a trick there that shouldn't be the case in my opinion, but very important for people that are having trouble displaying the cost maps, because then it's very important later down the road when you see that maybe your robot is not either finding the goal or it seems like it doesn't know where to go because it thinks it's stuck, and it might be because of a cost map configuration. Great. And that goes into my next question is that I noticed that every time you sent a goal,
yes,
it didn't fail. You know, usually when you set up nav2 for the first time, or when you have a package, you send it around and it fails a bunch of times. So how did you get it to be basically fail-proof here, that it didn't fail at none?
To be honest, I didn't do, I think, anything special. I took, I think, all the parameters exactly the same from the course.
From the course.
And I can't remember that I've changed anything.
Okay.
I think everything worked with the same parameters.
Yes, basically as long as
I've just changed the where it was for the simulation, so I'm using the real robot. Where it was something like I don't know, use sim or something like this was set to false, or it was set to true, so I then converted to false.
Yeah, that's to use the gazebo clock versus the real clock.
Yes.
But basically is taking care of making sure you know it's not going fast enough. You're checking that the inflation radius is not big enough, that your footprint's not, it corresponds to the robot. Just doing maintenance on that. I'm surprised it worked right out of the gate, and I'm glad. So the last question I have is, so you're saving the spots with that label, and you're getting some coordinates. What are those coordinates? Where are those coordinates coming from, and with respect to what?
Okay, so those coordinates are, I have two coordinates for the position of the robot. That's X and Y. Those are the exact coordinates of the robot on the map. And then I have another two coordinates that that give me the orientation of the robot. Those coordinates, I get them from, 1 second, not launch, spots recorder here. From this topic, AMCL pose.
Great.
This is the pose of the robot on the map.
Yes, which means
when it's localized.
You need to be localized in order to save these spots. Okay, and my question is, what do these coordinates depend on? So technically, you're taking a coordinate with respect to the map, you said, right?
Yes.
So basically, is the most important part, sort of, to know whether you're right or not, is where that map origin is at, correct?
I think the origin is in the left top point. So
no,
in the left top. No,
it isn't. That's what I wanted to get at, just because I think it's something that helps a lot. It's at where you started mapping.
Okay.
So when you
Yes,
start
it
mapping,
makes sense.
that publishing with the frames, which is what actually is coming out of the AMCL post. It's a TF reading of map versus your footprint, and that map frame gets published when you start mapping. So it's actually kind of important where you start mapping if you want to keep things standard, right? So
Yes, I've said firstly that I think is in the left top point, because today I've looked into this file, turtlebot underline area dot pgm,
yeah.
and I've imported in an online program. I don't know how it's called, to be honest, and that showed me the coordinates. And I don't know if this program has something specific, or but here in this one said that the top left point was 00.
Okay, yeah, but if you look at the YAM, the turtlebot
Yes.
area.yam, you'll have an origin in there.
Okay. So
That's
this is the point where I've started.
yeah. So if you actually go to your RViz and look at the frames. So you have one of those is the map frame. I think it's the
Yes.
bottom right. If you can add the name of it, I think it's in the TF element.
Here.
Show the names, yeah. Yeah, see, so it's actually
Okay, so here is the origin.
right from that
Okay.
point you're getting all those. But the PGM, is the PGM, so it probably starts at that corner. But this scenario,
Okay.
that's so you understand like the coordinates you're getting, because a lot of people are thinking maybe it's in the bottom right, and I don't understand the coordinates.
To be honest, first when I thought about it today, this is why was my intuition that the origin is where I've started mapping the map.
Mm-hmm.
But then when I've imported a PGM file in this program, I saw that the left top point was so I said, okay, maybe the robot, when it's mapping,
Yeah.
it uses the origin where I'm starting, and after it saves, it changes its origin.
Yeah.
This was my logic.
Right, yeah, it makes sense, and you can actually change that. So you go to the YAM, and you want to change that map origin, that frame though. You can go into that YAM and just put 000, and it will be on top of the start of that PGM. But
Okay.
unfortunately, you can't. Just so you know, you can't rotate it because otherwise the
Okay.
cost maps won't rotate with it. So it's like you need to go into the nav2 source code and basically rotate those cost maps as well.
Yes, it won't fit.
Yes. But anyways, that's the one thing I wanted to just mention on an otherwise really nice project. So
Thanks.
really, really nice, Dura. Congratulations, and yeah, that's it.
Thank you.
All right. So let me just switch back to me here. And yeah, guys, so this is what you can do when you take our courses in nav2 and set up an autonomous navigation application that actually works on a real robot. So here's a really small but comprehensive example of what you can do with this. So I encourage everyone to take our course and come present the project so you can obtain one of our certificates here like Dura has. That's it for us, guys. So we hope to catch you on our next presentation and see you guys next time. All right. Bye-bye.